Today we're going to finish Unit 3, Lesson 2. If you were absent, please get a copy of the activity from your teacher and then any notes that you missed. So we've already completed the first page of the activity. In the first page we actually developed the law of cosine rule. There are two patterns that the law of cosine is used for. One pattern is side angle side, which is where we will begin today. The other pattern is side, side, side. For side angle side, we're looking for the side opposite the angle. And for side, 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 we are looking for one of the angles that's opposite one of the given sides. So if you turn to page 2 in the activity, starting with problem number 8, this is where the three rules were given, and then we're going to look at problem number 9 after that. And if you have already gone past that, then you may want to advance in the video to the place where we left off. If you were absent, then this is probably a great starting point, especially once you have the notes from page 1 copied down. I'll be using two programs, so the file itself and then a program called Graspable Math. So these are the three formulas for problem number 8. The one thing keep in mind with the formula is that the angle we're working with and the side that we're looking for are always opposite each other. So I tend to put the a squared at the end of the equation. If you look up the formula, quite often they put the a squared at the beginning. The formula will look a lot like the Pythagorean theorem, and then there's plus a little bit more. These are all multiplication problems in here, so it's 2 times b times c times cosine of a. So keep that in mind that this is all multiplication here. Alright, so if you don't have the formulas written down, please copy them down and then turn the video on when you're ready to continue. So problem number 9, we're looking at 3 different problems. The length of B and C are given. We're looking for length of A at all 3 of them. The only thing we're doing is changing the angle measurement. So I want to start off with a 90-degree angle to kind of talk to you a little bit about the fact that the law of cosines is not restricted just to non-right triangles. This rule can also be used for right triangles, although we have other rules that are actually easier. And what I mean by easier, fewer steps to get to the final answer, but law of cosines will work here. Alright, so for the first one here, again, we're looking at for side A, which means this is angle A. So 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 90 degrees. And again, a nice thing about this is you can stick all of this in your calculator as one big problem, hit equals, and you'll get the answer for a squared. And if you do that, you should get a final answer for a squared to be 25. But anyway, for the steps here, we're going to square the 3 and the 4. And then go through the multiplication steps here, and the final answer, at least before we do the addition, is 9 plus 16 minus 0. Cosine of 90 degrees actually is 0, so 24 times 0 is 0. So the final answer, as I mentioned earlier, a squared, you should get 25. And then we take the square root of both sides. There are 2 answers, but since we're looking for the length of a triangle, then the answer is actually positive 5. In the second problem, I forgot to change this to 40 degrees, but we're looking at a 40-degree angle now instead of a 90-degree angle. So the problem is 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 40 degrees. Since 90 gave us an answer of 0 here, and the final answer was 5, since we're decreasing the angle measurement, the length of A should also decrease, so you should end up with a final answer that's less than 5. Alright, so 3 squared plus, which is 9, 4 squared is 16. If we go through the multiplication here, this time, instead of getting an answer of 0, we're actually subtracting 18.385 from 25. So we end up with 6.615. And once you take the square root of that, we're looking at an approximate answer of 2.572. And then the third problem for number 9. If you have not done this, turn the video off and complete this. SEP is very similar. 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 110 degrees. Since we are increasing the angle here, we should get an answer of a squared that's more than 25, or an answer for a that's more than 5. So again, 3 squared is a 9, 4 squared is 16, and then going through the multiplication here. The one thing I need you to be aware of is that the 110 degree angle is actually giving me a negative answer, and the reason why, and we'll talk in greater detail about this, but if you think about a 110 degree angle, if you're on a coordinate grid, once where 0 is on the x-axis and you go counterclockwise to 90, that's going to get you the y-axis. If you get past 90 degrees, then your x value is actually going to be negative. And with an angle measurement, which again we'll talk about in class, this cosine answer actually ends up being negative due to the fact that the triangle is in the second quadrant where x is negative. So when I multiply this, I'm going to end up getting a positive answer here because you had double negative, so it's an addition problem. So we end up with a final answer, again, it's going to be more than 25. So the final answer when we do the square root is approximately 5.763. If you jump down to problem number 12, there are 2 law of cosine problems where you're being asked to find the missing sides. So please set up the both problems. We're not using A, B, or C here, so I'll be using X, Y, and Z. But keep in mind that for the law of cosine, the equation itself always ends with the side that's opposite the angle that's given. This is a side angle side situation. Same with this one. So law of cosines, we're either using the pattern of side angle side to look for a side, or side to look for one of the missing angles. So please set the problem up, both problems up, and then complete them. Turn the video back on when you are ready to continue. Alright, so we start off with 18 squared plus the 25 squared minus 2 times 18 times 25 times the cosine of 38 degrees. Again, if you stick all of this in your calculator as one big problem, then you'll find the value of x squared. Take the square root of that to get to x. But for the program I'm using, I have to go through, we're going through the steps here. So we end up with a final answer of approximately 239.790. And so hopefully you find the length of x to be approximately 15.485. And then the second problem, 12, again the side opposite the 142 is the side we're looking for, so the equation is going to end with x squared. So it's going to be 6.8 squared plus 4.6 squared minus 2 times 6.8 times 4.6 times the cosine of 142. Here's an example of, again, we're past that 90, so you should expect that this cosine of 142 is actually going to be a negative answer. So under this, so hopefully you understand that. If not, I'm pointing out that you should get a positive answer here, because the structure problem really is essentially a negative 2.6 times another negative here. So going through all the steps. We end up with a final answer here of 116.698. That's for x squared. Take the square root of it. So hopefully you got an answer of approximately 10.803. Alright, so we're going to back up to problem 10. So in 1011, we're going to look at, or actually supply you with the formulas for law of cosines rewritten for an angle. So one of the things, like the quadratic formula, if we can rewrite an equation so that all the numbers go on one side, then we don't have to worry about doing any type of additional algebra steps to get to the value we're looking for, other than maybe like for missing side, doing that square root to get to the final answer. But like the quadratic formula, it's just plugging the numbers in, being able to utilize your calculator, and not have to worry about doing a lot of algebra. And that's going to be true for finding the angle measurement for the law of cosine. So here are the three formulas, or three different ways of writing law of cosines for angles A, B, and C. So I want you to look at the formula and recognize that if we're looking for angle A, then that means the C side, which is opposite angle C, is going to be squared, but it's going to be under subtraction. Same thing for angle A and angle B. So whatever letters we're using, the side that's opposite the angle when we're looking for the angle is always under subtraction. Everything else is under addition, and it's also under multiplication, both numerator and denominator. So go ahead and copy these three formulas down in the appropriate places for problems 10, 11, and then turn the video back on when you're ready to continue. So I'm going to finish up the two problems here with you in problem 13, and then this will end the first video. And then when you get to the next set of problems, there are some practice problems, I believe 10 total, and I will go through 3 of them, and I would like you to complete the rest of them with at least one partner. And then I'll talk a little bit about the additional work to do for homework. Alright, so for the first problem, 13A, again, we're looking for angle Z. So if I would put in the angle Z with the opposite side, which is 8, that tells me the 8 is going to be the subtraction part of the problem, and then everything else is going to be the 22 and the 18. So it's going to be 22 squared plus 18 squared minus 8 squared, since 8 is opposite Z, all over 2 times 22 times 18. Depending on how you want to handle your calculator, I tend to, at least in terms of my conversation, figure out the answer to the numerator as one problem, sticking all this in as one problem, and then find the answer to the denominator, again sticking all of this in, 2 times 22 times 18 is one problem, to get both numbers. And then from here, again, you can turn it into a decimal number, but we are looking for the angle Z, so that means we have to use inverse cosine. So it's going to be inverse cosine to both sides, and so it's going to be, to get rid of cosine here, so it's going to be inverse cosine of 744 over 792. So inverse cosine of 744 divided by 792. Which is going to give me an answer of approximately 20.050 degrees. Now, the program has a way of doing it, but the way that they do it is different. So I think I'm going to stay with the other calculator. It looks closer to what you are used to seeing, but I believe this will get us very close. So again, 20.050, and we had 20.4049 with a 9 after, which gives us the same answer. So it doesn't look like inverse cosine. It's called arc cosine, but I'm going to go ahead and use the decimals calculator instead, since it looks more like what you're used to. Alright, in the second problem, again, identifying the side opposite the angle we're looking for. In this problem here, so we're going to end it with the 5. So 16. Oops, sorry about that. So 16 squared plus 18 squared minus the 5 squared, all over 2 times 16 times 18. And then if I would finish off the numerator, I get this answer. And if I finish off the denominator, I get this answer. So I'm going to be doing the inverse cosine of 555 over 576. So inverse cosine of 555 over 576. So hopefully you got an answer of approximately 15.519 degrees.